We're going to take some derivatives of more complex functions in this next bit because I see I have t's divided by t's for number 7. Anytime you have a variable divided by a variable, you can use the quotient rule. So I'm going to take the derivative of what's in the top times the original bottom minus the derivative of the bottom times the original top all over the original bottom gets squared. So I have to take this derivative now, the derivative of the top, original bottom, minus the derivative of the bottom times the original top, all over the original denominator gets squared, giving myself space for each term. So starting with the derivative of the top, derivative of t to the 4th is 4t cubed. There's the derivative of the top. I get points just for copying down the original bottom. That is part of my derivative. It is 5t to the 6th plus 2. Minus, I need to take the derivative of the bottom. Derivative of 5t to the 6th is just going to give us 30. 5 times 6 is 30. And then we have 6 minus 1 is going to give us t to the 5th. Derivative of the bottom is going to be multiplied with the original top. All over the original denominator gets squared. So it's totally fine the first few times, especially that you do this, that you just give yourself parentheses. You don't have to, but it makes it so that I remember to do each piece. Derivative of the top, original bottom, minus derivative of the bottom times the original top, all over the original bottom gets squared. The next one, I don't have x's divided by x's. I have more than x to a power. So I'm going to use the chain rule for the next one. So my chain rule says to start just by bringing down the power. So I have 5. I'm going to subtract 1 from the new power, which will give me 4. The original stays on the inside, 6x to the 10th minus 9. And now we get to do our work here. We're going to take the derivative of the inside. I like to just put it in parentheses. In case it's more than one term, it does need parentheses if it is more than one term. So the derivative of the inside piece, 6x to the 10, will give us 60, x to the 9th, and the derivative of negative 9 is 0. So we brought down our power 5, raised it to a 4, and then multiplied by the derivative of the inside. We're going to do that exact same rule all over again, but I do have to do some algebra first because I don't have a nice 5th power here. I have a fractional power. It is a 1/2 power when we have the square root. So we have 8t squared plus 10. I'm going to use my chain rule now and bring down that 1/2 power. That way I can subtract 1 from the new power. 1/2 minus 1 is negative 1/2. So we keep that same inside piece raised to our new power. Bring down the power, subtract from the new power. Last part is multiplying by the derivative of the inside. Derivative of 8t squared is 16t, and the derivative of 10 is a constant. So derivative of 10 is 0. The next one is the exact same thing all over again. We have more than x to a power. We have it under a root again, so we'll have to rewrite it. I see it's a 3rd root this time, so it's going to be the 1/3 power. We would not raise it all to the 3/3 because that 3rd power there is not for the whole thing. If it was going to be something like 5/3, we would have parentheses. It would be the whole thing is to the power 5 over root 3. We don't have that here where we see parentheses and a big power for all terms. So it's just a first power for what's on the inside over the 3rd root. So we have 12 minus 4t cubed being raised to the 1/3. That's not the derivative, that's just rewriting the original. Now I'm ready to use my chain rule. I'm going to bring down that 1/3 power. Subtract 1. 1/3 minus 1 is going to give us negative 2/3. We have 12 minus 4t cubed on the inside still. And our last piece after we bring down the power, subtract from the new power, is to finally look at what's on the inside and take the derivative of it. The derivative of 12 is 0, but the derivative of negative 4 times 3 is going to give us negative 12t to the 2. 3 minus 1 gives us 2. So we did a quotient, we just did 3 chain rules. They just look a little different for each one, so it's nice to practice with them. And then we have our next one, x's times x's. We have a product rule. I'm going to call this the first term and this the second term because my product rule, I'm going to start by taking the derivative of the first, original second, plus for product, the derivative of the second times the original first. So just like we did with that quotient rule, I gave myself lots of parentheses. I'm going to do that here just so I don't forget a term. I'm going to do the derivative of the first, original second, plus the derivative of the second term times the original first. Lots of spaces. So starting with the derivative of the first factor here. Derivative of x to the 9th is 9x to the 8th. Our mini rule derivative of 1x is 1. There's the derivative of the first. I get points for copying down the original second. That is part of our derivative here. So we did derivative of the first, original second, plus now I'm going to take the derivative of the second term. Derivative of x to the 4th is 4x cubed. And then we have minus x squared, so it's going to have a derivative of minus 2x when we bring down that power. There's the derivative of the second, and now I'm going to just copy down the first factor. X to the 9th plus x. Derivative of the first, original second, plus for product, derivative of the second times the original first. So that looks like it is good to go. And we just did some extra practice with the quotient, lots of chain, and then a product.